now it is appearing in every place where I shoot. And if I'm covering myself with the wall, the shooting action does not pass through the wall. In the previous video, we set up our crosshair. We made sure it was center animated and responsive, so when we aim, everything looks and feels correct on the screen. But once we start shooting, a problem appears. Even though the crosshair is perfectly aligned, the bullet is not actually going in the direction we're aiming. It is one of those issues that immediately breaks the feeling of control in a shooter. And it is also one of the most common mistakes when building shooting systems in Unreal Engine. In this video, we are going to fix that problem. I will show you how to make your shots originate from the weapon's muzzle, but still land exactly where the crosshair is pointing. We will look at how to convert the screen space into world space properly, how to trace from the camera, and how to connect that result to a weapon in a clean and scalable way. This is part of a full video series on creating Mad Gameverse, my newest third-person shooter that you can follow step by step to create your own shooter. You can find the entire playlist linked in the description. This is the Game Creator Accelerator channel. I am Tony Munoz. To support this channel, like, subscribe, comment, share, and ring the bell so you don't miss new Unreal tutorials, strategies, and methodologies to build a successful path as a game developer. And now, let's get started. First, let's present the current situation. If I shoot at this moment in my game, as you can see, I am not aiming to the target that I want to shoot. This is what we're going to fix today. Every time that I shoot, we should have a trace directly to the center of the target. The first thing we do is to open the shooter character. And remember that you have access to this entire code on several videos of this YouTube channel, and you can start it from zero, guys. I will leave the link in the description. Now let's go to the method that I want to change today. Let's open the window for the Solution Explorer where I have all my files. And inside the shooter character.cpp, let's find the method named shoot button pressed. This is the action that will, as you can imagine, create the shooting effect. And here's where I'm going to implement several changes. So I'm going to add comments from this line after the shoot sound, go to the bottom, and I will only leave the last part where I am controlling the animation using a fire montage. Let's go to the top. And even though you haven't seen the previous lessons before, this will be great because we're going to start doing something different line by line. The first thing we'll create is a barrel socket. The barrel socket will be located at the point of the barrel of the weapon. The reason why we're going to use this is because we're going to create a line from the barrel socket to the position that we are aiming in the world. Now we'll continue with this suggestion, which is creating the socket transform. We'll get from the barrel socket, get socket transform, get mesh. And then we're going to define a vector where the muzzle is going to start. But because it's a muzzle, I prefer to call it, in this case, muzzle start. The next step is we having an effect on Niagara, which is a muzzle flash when we shoot. If you want to see how we created this muzzle flash, there will be a link in the description for it. Let's write if muzzle flash Niagara, and let's tap this to confirm that everything is correct. If it's easier for you, you can move this to another line to understand it better. At this moment, we have the Niagara function library to spawn at location. We'll start with get world, the muzzle flash Niagara that we're going to spawn, the muzzle start, which will be the position, and the socket transform rotation to set the rotation for this one. I want the same rotation for the socket transform. So let's leave it for a second like this. As I mentioned a moment ago, we are going to line trace now from the center of the screen position on the center of the crosshair to the impact position in the world. Imagine that we are creating a line that will go from the center of the screen to something that they will impact. Now we want to find the location of the crosshair, which will be in the center of our widget. So let's add a comment, something like get current size of the viewport, F vector 2D, and let's name it viewport size. Good suggestion. And now we are going also to use this to get the viewport size. First, we're going to confirm that we have the G engine and that we have the viewport. If that's the case, then we can call the get viewport size. And that, because it is passed as a reference in the parameter, will be assigned to the value of viewport size. Look that here we have an ampersand. That means it's passed by reference. That means that we are going to update this value. Once we have the size of the screen, now we can get the screen location of Crosshair. And here we have the suggestion, which is, well, for the Crosshair location, we're going to get the viewport size on X divided by 2 and on Y divided by 2. The value will be assigned to this new variable called Crosshair location. Now I want to check that we have a player controller. And for that, I'm going to use a player controller. We can call it player controller, but in this case, I will call it PC, so I don't confuse terms or reference to variables or methods. And then I will say, if not PC, return. The reason why I'm doing this is because now I am going to use other properties that won't work if I don't have a player controller. For example, the Deproject. Deproject will create a line that will go from the crosshair to the world. That is deprojection. And if I don't have the player controller, I can't do that. The first will be a camera world position. I'm going to call this one, rename it camera world position, which is imagine the position of the camera from where you are experiencing the game. The second will be the direction that we are watching from the camera perspective. So I'm going to call it camera world direction. Now we're going to deproject. And the deproject is a uGameplay statics that calls a method called Deproject Screen to world, which returns a boolean. So I'm going to create a boolean called const bool b deproject, and now I will use uGameplay statics, and let's check these parameters. The method I need is the Deproject Screen to world. The first parameter is the player controller, and because we have it here, now I can call the Deproject Screen to world. Then we have the crosshair location that we set previously here, and passing the camera world position and camera world direction. If you move the mouse over the method, you can see that the last two parameters are passed by reference, which means that we are going to update them. Let's continue. If not be deproject, then we can return and finish this process. Now let's start talking about collisions. F collision, query, params. Let's use the parameter params and pass scene, query, stat, shoot, trace, and true. I made a mistake here. This is a query. And now that I define the params, I want to ignore the actor. I mean the player that you're using. If we're going to create a collision, if we're going to read collision, I don't want to read collisions when I shoot that will be generated with the collision with my own character. I want to identify the collisions external to my shooter. It can be a surface, it can be any other object, or it can be another NPC. Let's say create a first step. I want to trace from camera along crosshair world direction. Let's start with a const float named trace range, and let's set it in 50,000. I can use this way to present it to make it clear for the reading. Now another const of type f vector that I will name aim trace start, which will start in the camera world position, and another const f vector aim traced end that will be from the aim trace start, and we're going to add the camera world direction, which will be in front of us, through the crosshair, and multiply by trace range to make it very far away. Now let's go for the F hit result of this hitting. I'm going to name it just aim hit. Create a const, which will be a boolean, for B aim hit. We need to confirm if we are hitting something. And if you go to the method, you can see that the F hit result, the first parameter, is passed by reference. So we're going to get a value of aim hit if the B aim hit is true. The other parameters are the start location of the array, aim trace hit, aim trace start, the end location of the ray aim trace end, the visibility, which will be of the type ECC visibility, and the params that we are setting for not detecting if we collide with our own character. I mean that our shootings do not collide with our own character. Finally, we create another const of type fvector named aim point, where we're going to check the boolean of BM hit, and if it is true, aim point will be the same as aim hit dot impact point, or else then it will be aim traced end. In other words, where the trace finally ends. I want to let you know that this channel is part of a bigger journey called the Game Creator Accelerator Lifetime Mentorship. It is built specifically for someone with limited time who needs direct guidance to build a solid path in the gaming industry, people that do not want to waste their time. The goal is a measurable transformation into a game creator, not just watching tutorials, not just collecting notes or certifications, but building proof through learning technical skills with direction, creating projects to develop the skills, and using proven strategies and methodologies to set up a brand for yourself and your creations. You and I work together to build your Unreal Engine games, learn core principles and how to solve challenges, and then grow your social media presence to share your work with studios, publishers, recruiters, and players, your future fans. This is the same approach successful indie creators use, myself included. But unlike me, you don't have to learn it the hard way. Today, learning in isolation, submitting applications, or developing without leaving a mark doesn't work. You grow by creating, sharing, and making opportunities come to you, not chasing them backwards. The GCA mentorship will help you transition to the work of your dreams without jeopardizing your current circumstances. If you want to learn more, visit woolon.com and schedule a one-on-one chat with me. The link is in the description. So far, all this sounds very good. But let's say that you are aiming and you have a very close wall to your character. In that case, the shooting don't get to the destination, but hitting the closest wall. That is the second part of this problem. So trace from the muzzle to aim point prevents shooting through walls. Let's create a F hit, result, muzzle hit, and now a const boolean. We can name it B muzzle hit. It will be another line trace single byte channel, but in this case we pass the muzzle hit, muzzle start, the aim point we obtained previously, the ECC visibility, and the params. Now let's get this value. Const F vector final impact point, and we will say if B muzzle hit this one, then the impact point will be the one of the muzzle hit, I mean the wall. If not, then will be the aim point. Again, this section prevents you from not shooting to a target that you can see far away while you are covering yourself with a wall. If that's the case, the shooting should stop on the wall. Now let's create the bullet beam. Beam VFX from the muzzle to impact point. Well, first of all, we have to check if we had a bullet beam Niagara. If you want to see how we created this beam, there is also a link in the description or to the previous lessons of this creation of this video game. Because we know that we have the Niagara at this moment, we are going just to create a beam component to spawn at this specific location. Let me move this one to the bottom so we can read it easily. The parameters we pass are the get world, the bullet beam that we spawn, the muzzle start, and the socket transform rotator. If we collect the beam comp, then we can define where this muzzle will start and when it will end. Again, to watch the details about how we created this beam, look in the description and the links corresponding to it. Now we also want to add a decal at the point of the impact. Of course, only if we hit something. So if first B muzzle hit, B muzzle hit, And if we have an impact Niagara system to represent the impact in that point, then we'll spawn that in the specific location. You can click here to move the parameters to the next line so you can read it better. And the impact decal material will also be spawned using the spawned decal at location. We're passing the parameter getWorld, the impact decal material that will present, the size that we set, the point where it will be spawned, and the corresponding rotation. The last parameter, which is the 20, is the lifespan for this decal. You don't want it to stick here forever. And for the impact Niagara, this is like a smoke of the zone that we impacted. And we pass parameters that are very similar, only that we don't use the duration for this spawning. It will end as soon as the Niagara system finished. Now we can close these comments. And the last section is about the animation. We also add this montage in previous lessons that you can also check on this YouTube channel. Now let's save. Now in Unreal, let's compile and test it. Okay, here we have our character and we shoot, and there we are aiming to the position. But what I'm seeing now is another error, which is that sometimes the decal appears and the smoke, but sometimes it doesn't. In this case, what is happening is that the camera trace is correct. Our muzzle trace is also correct in the logic. But sometimes the line trace is infinitely thin, so slightly offset edges, small targets can cause a legitimate misbehavior. So let's solve this problem. Let's go back to the shooter character implementation and to this step, which is the to trace from muzzle to aim point. I'm going to add a variable that I will call const float muzzle trace radius. And let's set it to 3.0f. And we're going to change this B muzzle hit. Instead of line tracing single by channel, I will use sweep single by channel. The most important difference is this parameter. You can see it here, which is the collision shape. And in this case, in our case, we are creating a sphere, which radius is 3.0. This will help us guarantee the impact. Now we're also going to add a const boolean b muzzle blocking hit, where we are going to confirm that the conditions of b muzzle hit and muzzle hit b blocking hit are true. And now the final impact will be b muzzle blocking hit, and if it is true, it will be muzzle hit dot impact point or else aim point. For the bullet beam in Niagara, we are not going to do any changes. But for the impact of the VFX, we first are going to confirm that we have b muzzle blocking hit, and for the rest, I think that we'll leave it as it is. Let's save and test it. Compile in Unreal and play. Now it is appearing in every place where I shoot. And if I'm covering myself with the wall, say that I'm close to the wall and try to shoot, look that the shooting action does not pass through the wall, which makes sense. But if I move away from the wall, then it is there, and here I should have my decals. Excellent. With this in place, the shooting system is finally doing what it should have been doing from the start. The crosshair, the camera, and the weapon are now working together, and every shot goes exactly where the player is aiming. You also now understand why this problem happens and how to solve it in a way that scales as your game and your systems grow. Remember to like, subscribe, comment, and share, and ring the bell so you do not miss new Unreal tutorials along with the strategies and methodologies to build a successful path as a game developer. And don't forget to visit woolon.com to learn more about my mentoring program and to set a chat to talk with me directly. The link is in the description. And here's a new video where I talk about why starting with small projects might not be the best way to kick off your professional game development career. As always, until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.